I don't think I can follow that bill. Sorry to disappoint you. Right, thank you so much. Yeah, I don't think I've enjoyed an annual general meeting as much before in my life, actually. Yeah, it's such a warm welcome, and thanks, David, for inviting me. Well, the title is there, Wastewater in the Wharfe Ilkley story, and I think first of all it's an apology because I didn't think about this until after I finished preparing the talk, but I don't think there's one slide with a fish on it, and you might spot it later on, in fact, so apologies, in fact, really. But having listened to that presentation about what you intend to do and what you are doing, it seems to me that this refocusing on the whole river system and its ecology and improving the health of the river for the benefit of all wildlife, and ultimately, of course, for the fish that you're specifically interested in, is actually to be really welcomed, and it's very heartening, in fact, really, that you're actually paying so much close attention to that bigger picture, in fact. So I wanted to just, let's see, say a few things about the work that we've been doing in Ilkley and on the Wharfe, how the Ilkley story began, a little bit about fecal bacteria, and the bathing water status has been referred to already, and you'll know that Ilkley has this accolade of having the first running water designated bathing status in the country. Where the fecal bacteria come from, and again it's this question about sewage and agriculture. The bigger project, I think, was mentioned as well. We started on Ilkley and the Ilkley stretch of the Wharfe, but then we expanded to look at the whole river, and it'd be a lovely possibility to think about that as an idea for the NID. So we called it the iWharfe project, and iNID,
Sounds good.
possibly. And with Malcolm here, we can advise and help as much as if you ever wanted to go in that direction, we would be very, very happy to help. And then I want to just change the pollutant, because most of it, the first part will be about fecal bacteria, its impact on human health, and whether the river is fit for people to swim in. But maybe from an ecological point of view, it's more the nutrient pollution that's of concern. And so towards the end of the talk, I'll focus on nutrient pollution. And then right at the end, I've got the bit on the NID, and that's because we have some data already working with David on the NID. So perhaps you've never been to many talks which starts with a visit to the local sewage works, but I thought I would start just with this map of the sewage treatment works in Ilkley. And you can see, interestingly, that it's a sewage works, unlike many on river systems, that's actually right in the centre of the town. Quite often they're downstream of the town, they're hidden away, and the outfalls into the river are actually hidden away as well. But these, which is great from our point of view of transparency, they're very easy for everybody to see what's being discharged into the river. If you know Ilkley at all, you can see here the Crumwheel corner, there's a footbridge across there, and then here is the sewage works. It's taking not just sewage from the whole of Ilkley, but also from the village of Addingham, where we live, about 3 miles up the road upstream. And the Addingham sewage pipe comes in under the golf course, it's slung underneath that bridge, and it comes into the sewage works. So that's one of the first points to make, in fact, that we might have hydrological catchments which are easy to understand in terms of where water flows and gravity, but often sewage systems are actually more complex because there's a lot of pumping that goes on, and you can be actually taking sewage from other communities into a main sewage treatment works. But what we have, and this is critical, is we have 2 discharge points. There's the one that you would normally think of where the treated effluent is discharged downstream of the sewage works itself. But there's also, these are the discharges that have been making the national headlines, This is where the untreated sewage is discharged when the volume of sewage and rainwater coming into the sewage works is too great for the sewage works to treat, and that then is actually discharged untreated into the river. And what's quite good from our point of view in terms of studying this system is that it's a separation between the point at which the untreated effluent is discharged and about 50 to 80 metres downstream where the treated effluent is discharged. So this is how it began. Kathleen Roberts, who was one of the founders of the Ilkley Clean River Group, and her partner, Steve Fairbairn, observed the discharge point. This is what it looked like in February 2016, and they thought this didn't look very nice, and complained and reported it to the Environment Agency and to Yorkshire Water. And Yorkshire Water acted very, very swiftly. And then a month later, it looked like that, which is a great improvement, except of course the stuff coming out is still untreated sewage. And on that occasion, this is what the river looked like downstream from that pipe, severely polluting the river with organic matter. And it's not just the organic matter that's not being treated. That untreated effluent is also full of fecal bacteria, and it's full of nutrients. 2016, Steve Fairbairn, and that's Steve on the bottom right, and Kathleen Roberts in the middle there, they complained for 2 years. They kept on reporting incident after incident. And Yorkshire Water and Environment Agency both said there's not a problem because all this is permitted under the licence. And so it is, in fact, that when the flow into the sewage works was greater than, I think, about 146 litres per second, they were allowed to put anything over that amount directly into the river. It was at that point that Steve and Kathleen talked to this lady here, Karen Shackleton. And Karen, who's a dog walker, and she walks along the river very, very frequently. And she thought this was really horrifying and wanted to raise the issue and try to get the whole of the Ilkley community involved. And what she did in 2018, she contacted this lady here. This is Becky Mulby, who's been the real hero because she's been the leading campaigner in the Ilkley Clean River Group. And they got me down there as well as a scientist to come along, form this Ilkley Clean River Group, just the 5 of us, to try to get this sorted out as best we could. So I came along essentially to say, well, the straightforward thing to do, of course, is to let's get some numbers. Let's find out, in fact, what the concentrations of fecal bacteria are in the river, upstream and downstream of the sewage works. And what we need to do then is to ask the Environment Agency for these data, or ask Yorkshire Water for these data. And of course we found out at that point, and it surprised me, even though I've professionally been in this business for a long time, that in fact the Environment Agency don't monitor for fecal bacteria in rivers. They only monitor fecal bacteria in sites that are already designated for bathing water. And these are the ones on the coast or in some standing waters. None of the rivers have fecal bacteria monitoring. And so the situation was then, well, if nobody's doing it, we'll have to do it ourselves. And that's where the citizen science work began. How do we actually measure it? What kind of samples do we take? What we were concerned about was that people use the river for recreation both upstream and downstream of the sewage works. Upstream is the most popular area, as you see on the left there. That's just where the suspension bridge is. Very popular. But downstream, there's also a beach there, and many local people use the beach downstream, often to avoid the busy upstream section. But this lady here is just sitting there at Beanlands Island, in fact, only about 50 metres below the sewage works. Not the best place to be taking the water. So we were concerned about downstream. Clearly people shouldn't be using the river for recreation downstream. Upstream, we thought may be okay, because the main source of pollution is the sewage works. So we got up together, we decided to have a citizen science project, measure the fecal bacteria ourselves, but what we needed was a source of funds, and I was a bit concerned about that because I thought this is going to be quite expensive because we can't do this at home, we can't do this by just looking at water samples. We have to take samples and they have to be sent off to an accredited laboratory, and we have to pay the going rate for the analysis. But we were very fortunate that Ilkley Town Council came up with quite a lot of money to help us. We got some money from the Rivers Trust and we got some money from the Wharfe Naturalist Society. It was enough to get started. What were we looking for? We were looking for 2 indicator bacteria. This one that everybody's familiar with, Escherichia coli, or E. coli, that's what it looks like in a scanning electron microscope. And the second one, intestinal enterococci, this one Enterococcus fecalis. Again, you can see what this looks like in a high magnification microscope. It turns out that we ended up essentially looking at E. coli because it's expensive to look at 2 different bacterial populations, and the E. coli data was sufficient to indicate, in my view, what was going on, and we didn't need to go to the expense of analysing for both of these bacterial groups. Sampling is really very, very straightforward. It's a question of walking, and this is where it's useful to have angling community involved in this, because well, Steve, the 2 Steves here, I think probably many people in the room will know them, that they're actually very experienced anglers, fly fishers, and they've got all the kit to actually get into the river and take samples directly. But in higher flow, we can take samples by a throw bottle, or we can take samples by dropping it off a bridge. But we take samples in bottles like these. These are supplied by the company, and we keep them cool between 2 and 8 degrees centigrade. Take them down to Wakefield on the same day, and then they're delivered overnight to Coventry, and the analysis starts within 24 hours of them being collected. That's very important. Take the samples, keep them cool, get them to the lab and get them analysed within 24 hours, because as you understand, bacterial populations are likely to die really quite quickly. So what we did to begin was, going back to this map, is saying where shall we take our samples? We'll need to take samples above the sewage works here at the Cromwell Corner. This is where people essentially are using the river most, and it's a point where currently the Environment Agency now takes samples for bathing water status. Some samples upstream at the old bridge, samples in between these 2 outflow points, the untreated and the treated outflow, and then down here in Beamer's Island that again is being used for recreation, and then further down towards Denton Bridge. So a series of about 5 or 6 sampling points upstream and downstream of the sewage works. The first thing to point out is that the concentrations that we find in the river depend massively on the weather conditions and the flow in the river. But before I show you those data, just to say that what are we looking for in terms of concentrations that we might find safe or unsafe. And this is a guideline from the Bathing Water Directive. It was an EU directive, but that's now been absorbed into UK law, but it might get repealed this week, or is it? This is one of those 2000 laws, in fact, really, that's going to be repealed and replaced by something perhaps the same or different. We don't know. But this is the existing legislation. And these are the 2 bacterial groups that I mentioned, E. coli and intestinal enterococci. And the concentrations in the water that the samples need to be below for it to be for it to achieve those different levels of quality. So excellent quality, good quality, or sufficient. For the purposes of the talk, don't worry about the details here. Just think perhaps of this figure here of 1,000 and say, let's say that 1,000 is a figure that we can use. If it's more than 1,000, we can say it's actually unsafe. If it's less than 1,000, we can say it's not too bad or so. But we're looking, use that level of 1,000 as a yardstick. In reality, this is used in a somewhat different way because these are based upon percentiles, and it means that, for example, to qualify a particular standard, it needs to be more than 20 samples taken in a season, and then look at the statistical distribution of those samples, and then calculate either the 95% or the 90 percentile of that distribution to come up with these figures. But let's just stick with a simple figure of 1,000 as being a yardstick. And so the first time we went out, by chance, it was wet and there was high flow in the river. This is in June 13th, 2019. And you can see the sewage works here and the river and our sampling sites. And the numbers in red are the concentrations of E. coli in 100 millilitres of water. That's a couple of shots of whiskey, something like that, a little glass of water there. And what's interesting is that here we have this very high figure of 32,000, and that's a sample taken between the untreated and the treated. So on this particular occasion, there was a spill of untreated sewage into the river. As we go downstream, you see it decreases, and that's partly because the bacteria are dying off as we go down the river. But what was, of course, interesting was that upstream of the sewage works, we also have, on this particular occasion, very high values. So it's not always safe to be actually swimming in the river upstream of the sewage works. A month later, we went back. So the question is, where does that come from in those conditions? A month later, we went back in low flow, and you can see that the numbers are quite different. We don't have high numbers between the untreated and treated effluent pipes, clearly because it's dry conditions and there's no discharge on this particular occasion. But downstream of the treated effluent pipe, we have these extremely high numbers of 35,000. And then upstream, at all the sampling sites upstream, we've got really very low levels, suggesting that upstream in dry conditions, things are much better. But even in warm, dry conditions, downstream, we still have very high numbers of E. coli. And that's because the E. coli are not just coming from the untreated effluent in wet conditions, they're also coming 24/7 out of the treated effluent. So treated doesn't mean treated to remove the fecal bacteria, it removes the organic matter. It's still got a lot of bacteria in there. And I've shown this a few times, and this is just to illustrate it. This is a treated discharge from the Ilkley sewage works coming into the river. It really looks lovely, it looks good enough to drink. And to prove it, I've taken a sample from here, that's in this glass there. I've taken a sample from our tap water in our kitchen in Addingham and sent both of them off to the lab. They both look the same, they're both in whiskey glasses, and you can see that in the tap water at home, wonderfully well, it's zero, it's sterile, and it should be because the Yorkshire water has done their job and they've made sure that there's no fecal bacteria in the drinking water. If you look at the water from the treated effluent, which looks just the same, there is 500,000 E. coli in 100 mils in there. So pollution is not about what it looks like. You have to actually do the analyses and understand what's going on to work out what's safe and what's not safe. So we're able to conclude after just those two visits, doing some very simple citizen science, that the E. coli concentrations are very high downstream in wet weather during storm events, but they're also very high in dry weather owing to the continuous discharge from the final effluent outfall. In other words, bathers downstream are always at risk, and in fact they're more at risk from the treated effluent because that's the time at which you're more likely, you're not going to go and enjoy the river when it's raining and the river is roaring past. You're going to go when it's warm and sunny and attractive, but that's still the time at which the treated effluent is discharging high concentrations of fecal bacteria there. But interestingly, E. coli concentrations that we saw from the first data set can be high in wet weather upstream, but they're usually low in dry weather. And so we could advise local residents already by 2019 that bathing in dry weather upstream is relatively safe. This is all very interesting, but it didn't actually make any impact whatsoever on the attitude of the Environment Agency or Yorkshire Water. This was at the point at which Becky Maltby and the Ilkley River Group thought it was time to actually up the ante. And with the support of John Grogan, who was our MP at the time, and it's good to know that your MP is actually taking the fight on. We have a different MP now, but he's also equally supportive. There was a town meeting, and you can see the town meeting here, arranged in the Ilkley Grammar School main hall. And it was a collection of a lot of very angry local residents and two rather embarrassed representatives of Yorkshire Water, the Environment Agency, trying to defend their position and saying it's all permitted, therefore there's no problem. Clearly there isn't, because people can actually see just what a state the river is in when untreated effluent is being discharged. And at that meeting was pivotal because, and I think you've made exactly the same point already, that the way to get some purchase was to say, well, let's go for bathing water status. And that was John Grogan's proposal, although I think somebody had actually suggested that to him, in fact, really. So again, the politicians always take the credit for these good ideas. At the time, I thought that's crazy because there's so much pollution in the river. We would never get bathing water status. But then it turned out, in fact, that the bathing water status is not based upon the quality of the water. It's based upon the popularity of the bathing site, in fact, for people entirely. It's then up to the water authorities and the Environment Agency, in fact, to change the water quality to make it suitable for people. And that made all the difference. And it meant that from that point onwards, the Ilkley Clean River Group got together and organised counts of people using the river. And there's this, and we'll know this from the Nesborough work that's going ahead, presumably currently, in fact, that the data has to be gathered on the numbers of adults and children using the river, whether they're swimming, whether they're paddling, whether they're canoeing, whether they're on the bank or in the water, for example. And that's the data that we collected. I don't think I've got the data there, I haven't. I want to be going back, so there. And so in 2019 we set about collecting all that information, and I think the first weekend of the school holidays in 2019 in August, there were 2,000 people down actually at the riverside in Ilkley. So being able to demonstrate that this was a very popular site for residents and visitors to Ilkley was not at all difficult. So when we made the submission to DEFRA, it was essentially about the popularity and the opinions of local people, but it was supported also by the citizen science work that we'd actually been doing. The other question was, well, to what extent, in fact, is it likely to be successful anyhow? Because, as you can see from this map, there are no bathing water sites in the UK inland, except for a few on lakes. There's 4 on Windermere, there's the men's bathing pond, I think, in Hampstead. There's 1 or 2 others as well. But as you can see, they're all around the coast there. So what are really the chances of getting bathing water status for a running water site inland? Again, we were boosted, in fact, by the observation that if we look to continental Europe, they're not just dotted around the coastal area there. There are a lot of them inland. And if you look at the statistics, we can actually see that for these countries, there's many designated rivers as well as many designated lakes inland. And in France, there's over 500 rivers designated as bathing water sites. At this time in England, these were the figures in 2019, 0 rivers, 16 lakes. A year ago, it was 1 river 16 lakes. It's now 2 rivers 16 lakes. But there are a lot of applications in the pipeline, I understand. So this number is going to increase really quite significantly very quickly. Anyhow, the application, as we know, was successful. 22nd of December 2020. This is taken from the government website. Ilkley gets green light for first river bathing site in England. First job done. You can look on the Environment Agency website, and there we are. There's Ilkley in the middle of the Pennines there. And because in 2020 we had no analyses of the quality of the water, it was designated as being unclassified. This is 2 years ago, so we now have 2 full bathing water seasons under our belt. And these are the data, again, on the Environment Agency website, easy for anybody to look at. And these are based, as I mentioned before, on taking 20 samples through the season, so you can calculate those 95 and 90 percentiles values. But you can see that on 2021 data here for E. coli and for intestinal enterococci, and here 2022 data. This is last summer's data. I can put in that 1,000 CF bacterial concentrations per 100 ml of water there, and you can see in 2021 these are the measures. Most of them in fact were less than 1,000 there, but there are a few actually are higher. And then again in 2022 it was quite a dry, warm summer. The values were really quite low, but in May we had a high value, and then again in September when it started to rain again we had 2 high values. And as a result, even with those good values at the end of the season, then the classification for Ilkley here is that latest annual classification is poor. It fails. In fact, it doesn't even achieve the minimum standard for bathing water. So after 2 years, obviously nothing's been done yet to improve the quality of the water. All these figures are essentially dependent upon existing pollution sources and weather conditions. The designation stands for 5 years, so there's only technically 3 more years, in fact, to actually get those values down before the site would normally be de-designated. So that's one of the questions for the future, that if after 5 years a site has not achieved the values that are required to maintain it as a bathing water site, what happens next? One assumes that there will be some mechanism whereby, in fact, this is not de-designated, but it's a continuing program of improvement until the values come down and it becomes safe to swim in. But this leaves us then with the problem that we've not only got the pollution from the sewage works itself, we've got pollution from upstream sources. And where do those pollution sources, where are they? And it comes back then to this issue about agriculture and people. And again, there's a parallel with the NID, I think, because it may well be that if you're in Knaresborough, it's going to be dominated by Harrogate and Knaresborough and those big sewage works. But when you come upstream from Harrogate, you've got the mixtures we have of small communities and lots of agriculture. And those sources are going to be important and going to vary depending upon different conditions and different source trends. And this is where there's still a fair amount of contention in the Wharfe about what the sources are and how these sources might be controlled. For us, there's one obvious source in very wet weather, and this is from Addingham. Addingham no longer has its own sewage works. On the maps, it's still shown as a sewage works there, but this is essentially a pumping station. And the sewage from Addingham, a village of about 3,500 people, it gets pumped under the Ilkley golf course, as I mentioned before, and into Ilkley. But when it rains heavily, then the pumping station here is overwhelmed and it discharges directly into this mill stream here and then eventually into the River Wharfe. And in those conditions, slugs of dirty water go all the way down to Ilkley and create concentrations of bacteria at the bathing water site, which then are higher than those safe limits. So that's one source. And this is what it looks like. This is from 2019, but I was down there just a week or so ago, and when it was raining very heavily, and this is what it looks like about 30 or 40 times a year. It's all hidden away in the bushes. You've got to scramble through the hawthorns, in fact, to actually find that point. But that's what it looks like. That's the untreated effluent from the pumping station into this old mill stream and then into the River Wharfe. But what about agriculture? Well, here we are at Bolton Abbey. You can see that cows seem to be programmed, in fact, to relieve themselves as soon as they actually get to the water's edge. But there's a lot of soil erosion going on that bank there. There's a lot of fecal bacteria associated with fecal material from cattle and sheep. And when it rains, that water gets, that soil, that contaminated soil, gets washed into the river. And if you think that a cow actually can discharge a lot more fecal bacteria than a human, then in fact livestock has to be quite an important source of downstream fecal bacteria. It's not just on the main river, that's on the River Wharfe at Bolton Abbey, but we've also looked at lots of the tributaries, and just in the way that you're interested in looking at Darley Beck here, we've looked at lots of the becks upstream from Ilkley. We've got Town Beck in Addingham, we've got Hambledon Beck at Bolton Abbey, we've got Lum Beck in Addingham. And on this particular occasion in August 2021, when we had relatively low concentrations in the main river, we had extremely high concentrations in the tributaries. You see 7,000, 9,000, 7,000. Now these are somewhat complex tributaries because the tributaries again have scattered farmhouses with septic tanks, there's small villages, there's road runoff, and there's agricultural sources. So it's not easy, even in a small what seems to be an agricultural catchment, to pin down the real sources of fecal material. But it's pretty clear that the common factor in these three catchments here is the agricultural land. And the fact that in fact it's after rainfall that the concentrations increase suggests that's coming from agricultural land. Because if it's coming from septic tanks and small private sewage works, which are fairly common in tributary catchments, those concentrations will be diluted by a higher rainfall, not increased. So suspect that agricultural sources in these kind of conditions really are quite important. Then the question for us again, and it's the same question on the nail exactly, well, so far we've been looking just at these sites where Ilkley and Addingham, the sites more or less closest to Ilkley and to the bathing water site. But how far do we need to look upstream to find sources of bacteria that might be coming all the way down to Ilkley? And this is very complicated because it not just depends upon river flow and weather conditions, it also depends upon the rate of die-off. So the discharge of fecal bacteria in the river, in fact, starts to decrease. But it's very difficult to actually work out exactly what the rate of decrease is, because again, that varies with weather conditions. In summer, with high UV radiation, there's a lot of killing of bacteria, and the decrease is going to happen really quite rapidly. In other conditions, with colder conditions, or if a discharge at night time when there's no solar radiation going on, then those bacteria might get transported much further down the system, in fact, before you lose them. So one of the issues is how far upstream do you need to go? This is a critical issue for Yorkshire Water because they want to know how far upstream they need to actually treat their introduced treatment processes into different sewage works. So in our case, there is a question about Grassington. Grassington is a small town with Thrushfield and Linton communities bringing their sewage works into that sewage works at Graston there. That spills quite frequently. There's a continuous discharge from Grassington, but how much of that really comes down to Ilkley? So all this work is going on at the present time to try to work out where the sources are and where the investment needs to be placed.
Right, you've got 10 minutes.
10 minutes to go, I've been told. Okay. So with that in mind, this was a point at which we thought we need to look at Ilkley in the context of the river. And this was the main emphasis then of our citizen science work. Working around Ilkley, we didn't need too many helpers to do the sampling and the work. But if we want to look at the whole river, knowing that in fact the concentrations of fecal bacteria are going to be strongly influenced by weather conditions. We need to take the samples all at the same time, but this is over 125 kilometres of water. And so one of the great things about citizen science is that you can assemble teams of people to actually sample sites all at the same time. And we divided the river here from the headwaters in Upper Wharfedale right the way down to the junction of the Wharfe with the River Ouse south of York into 5 zones, as you can see here. And we have 5 teams out sampling about 10 to 12 sites each. And we sampled the whole of the river in the same weather conditions in the morning. And I don't think that's been done before. It's what I now call synoptic sampling, and it's actually marvellous the kind of data you can get by doing that. And I'll show you the first data set we got from that then was the concentrations in the blue here of E. coli, and then the red was the intestinal enterococci. And that no surprises about this is in high flow conditions. There's a big peak at Ilkley. But what surprised us going upstream was that these are these high concentrations. This is Grassington, Kettlewell, Coniston, Grassington, Burnsall, Appletreewick, down to Bolton Abbey here, Ilkley, Otley, Wetherby here, down to Tadcaster, the river there. And you can see the importance of Ilkley there, but you can also see that there are sources upstream. But, and this is my contention with Yorkshire Water, we can actually see that there's a big decline from Grassington coming down the river, and by the time we get to Bolton Abbey, the concentrations on this particular occasion were relatively low. So my contention is that probably the bacteria coming from Grassington are important for that Grassington area, important down as far as Burnsall and possibly Appletreewick, but probably not important in explaining the high concentrations in wet weather in the Ilkley area there. So we have a rapid die-off there. Anyhow, so I wanted to switch from this emphasis on fecal bacteria, where we have most data, to talk a little bit about nutrient pollution. And nutrient pollution is the pollution from nitrates and phosphates, which cause the main ecological problems on the river. Fish are not particularly worried about the fecal bacteria. What fish and invertebrates are more influenced by are the nutrient conditions in the river. And we've got the same potential sources because the nutrients are coming from sewage effluent and from agriculture. There's a concentration in importance in terms of phosphate, and as you probably know, the problem of nutrient concentrations, excessive nutrient concentrations, is it creates excessive algal growth, and you see this with algae growing on stones and other surfaces, and this is what we call eutrophication. It alters the food web, decreases biodiversity, and it's not only a local issue, it can have bigger problems further downstream, particularly down in the lower river and in the estuary and even in the North Sea. So some of the problems that we see in our seas is all the result of the discharge of nutrients from inland sources. The chemistry doesn't decay, the bacteria disappear in fact, but the nutrient discharge will continue to be carried downstream and continue to be recycled through algal material and through plants and be re-released in fact and then used to actually grow even more plants further downstream. So it's a major issue, and it's one of the reasons why most of our river systems fail under the Water Framework Directive. So again, here are the sources of nutrient pollution, not just fecal bacteria from the treated effluent, but also high concentrations of phosphorus. Top right-hand corner there from agriculture, we have their crops growing right to the edge of the river there, farmers putting on fertilizers there. Some of those fertilizers will find their way into the river, and again we've got our favorite cow there, creating nutrient-rich conditions at the edge of the river. That's not the Wharfe, by the way. I got this after the website. It was a lovely picture, I thought, but it comes from Ireland, but it just shows in fact really what kind of conditions you can create on the edges of watercourses that can cause soil erosion and nutrient pollution. This is what it might look like in our systems, algae growing on stone surfaces, and this is now unlike the fecal bacteria, something that is regulated by the Environment Agency through the Water Framework Directive, which was established in 2000, came into force in 2000, and has been hailed as being a major driver for achieving sustainable management of water in the UK for many years to come. The initial hope in the year 2000, when it came in, that all rivers in Europe would achieve good ecological status by 2015. That was then adjusted to 2027. It now is some long way into the future. It's a major, major problem to achieve good status. How is it assessed? Well, this is where you see the fish. It's assessed in different ways, as you can see on the left there. But the important thing about the Water Framework Directive is that the classification is essentially based upon ecology. And for nutrient enrichment, the best indicator are these guys here. These algae, but in particular these type of algae called diatoms. And so as well as actually measuring then the chemistry of the water, especially the nitrates and the phosphates, we want to look at the algal populations and the extent to which these change as indicators of nutrient pollution. And the classification, a bit like the bathing water directive, is shown there. A very simple one, five classes: bad, poor, moderate, good, and high. And in the Wharfe, we're actually in this high good area there. I think in the NID you're somewhere a little bit below this line. And this directive allows the agencies to make a classification like this, and they're required to prevent any deterioration. It should have been if it was good and then it becomes moderate. But they're also required to restore from bad, poor, moderate towards at least good. The problem is, for us in some parts of the Wharfe, is we're good. We should be high, but nobody's interested in going from good to high. I always say that my wife was a primary school head teacher, and if she was a good school as a primary school, that was not good enough. You needed to be high. And so it's a bit frustrating, in fact, that we don't have the resources to make all our watercourses, even if they're already good, better than good. But it comes back to the NID as well about are they the priority water, and it's going to be after 2050 before you actually have to look at that. This is the ecological status for the water bodies for Yorkshire at the current time. It's being reviewed at the present time, and you can see the colours. There's no blue except for this dot here, which is high. These are the green in the upper Wharfe there, which are good, and then most of it is yellow, which is moderate. You see the orange, some poor. And there's some red there, which is fail. And you've got a catchment here, in fact, which is
Ashfold side back.
Fail there.
It's Ashfold side back. It's
that's the top. That's like
heavy
metals pollution there.
Heavy metals from Greenham.
Yeah. And so when we did the iWharfe project for fecal bacteria, we also did it for nutrients. And other chemistry. So here's measuring pH and temperature and dissolved oxygen. You can measure that accurately in the field, but samples for nutrient chemistry, again, you can't measure accurately in the field or in a domestic situation. They have to go to a high quality laboratory to get accurate results. And then the diatoms, this is me up at Hebden Bridge, if you know that part of the Wharfe there, a very high-tech sampling system whereby we take a stone and we scrub off with a toothbrush that brown biofilm, that slimy biofilm that you see on a stone surface, and then we take that and we look at what's growing on that surface. And here are the pictures taken by Malcolm with his microscope at home. Stone with diatoms scrubbed off. Just looking down the microscope, you can see different diatom types here with their cell contents intact. What we need to do to be able to identify these diatoms, though, is to clean them up in the laboratory to remove those cell contents so we can see the fine structure of the cell wall. But those biofilms are not just diatoms, there are other algal groups as well. And again, these are pictures by Malcolm of different kinds of green algae that are growing on the stones. Lots of beautiful shapes, wonderful world, micro world in fact. And all these are food for the invertebrates. This is all wonderful food. So you talk about the base of the food chain, it's not the mayflies and the stoneflies. In fact, they're dependent very much on the algal growth. And this is a food that the mayflies love to scrape up. It's just like the cows and the grass. This is the grass in the aquatic system. And what we do for our diatoms, we take them to the lab, we clean them up and prepare slides. Look at them in the light microscope on the left or a scanning electron microscope on the right. This is one of the species that you have in the NID that we have in the Wharfe. It's very abundant. On the right you see how it looks like in real life, more or less. Here you see with a light microscope, just cleaned up so you can see the fine detail, and then you can really see the fine detail with the scanning electron microscope on the left. And you can see that there's so much intricate detail there that it's possible, once you've gone through this process, to actually identify these diatoms to species. And it's the different species that indicate differences in water quality. Here's another one, Melosira varians on the left, a live specimen on the right, and on the left a cleaned up specimen. And here's another few diatoms again from the Wharfe. And the one on the right you also have abundant in the River Nid as well. I'll show you in a moment's time. Yeah? Time is it now? I think, am I all right to keep going?
Yeah, just a few minutes, I'm afraid.
Okay.
Supper will be coming soon.
Yeah, okay. So very, very quickly, on the Wharfe, this is our data from the upper Wharfedale right the way down. Here is Ilkley, okay? And this is the phosphorus, so you can see very, very low values until we hit Ilkley, and then it's relatively high downstream. Here the diatom data, we come all the way down to Ilkley here, and this is where the main diatoms change. And if we draw some lines in there, that's change in the chemistry and change in the diatoms occurs at exactly the same point. So it's the Ilkley sewage that causes the biggest ecological damage in the river. But the diatoms also show that we've got something happening at Grassington too there, which is not picked up in the chemistry. So it's the diatoms, the biology, which is telling us more about the ecology, the condition of the river, than the chemistry, because the chemistry is very much dependent upon weather conditions. The diatoms are there pretty much all the time. I'll just jump ahead now, because to finish off, I wanted to show you a little bit about the NID. This is a bit on the NID just to finish with. And here's that diagram again. The arrow this time is pointing, I think, to this catchment here, which is the Environment Agency called the Upper NID operational catchment. We've mentioned this red tributary here, Darley. That must be perhaps this one, is it? I think. And quite a lot of that, according to the Environment Agency, is only in moderate condition. And the small amount of work that we've done with David, in fact, actually confirms that. These are the sites that we sampled in December. I think we've got these names right now, have we, David? You're happy with these? Duffers Pool, Darley Footbridge, first sleeper pool and second sleeper pool. And the sewage works from Darley enters the river just downstream of this site about here. So we were interested here in comparing the diatoms upstream and downstream to assess the extent to which the Darley inflow was causing problems in the river. Here's our on secretary inspecting a stone and sampling from it. And then on the left we have the data from just those 4 samples. And you can see on the left here, the 2 samples upstream. This is the point of entry of Darley Beck, which is relatively polluted beck and downstream. And here is a classification according to the Environment Agency's Water Framework Directive. So here we've got moderate, poor, moderate, moderate. The difference between these is very small. It's probably on the border, but it's a poor, moderate system according to the diatoms. And as you can see, there's very little difference between the kinds of diatoms we see downstream from upstream. The reason why this one is poor is because there's a higher abundance of this particular species at that site. If we sampled many times, it might be that it disappears. That's a species again, Amphora pediculus there. But that's interesting to already begin to conclude that the water is polluted further upstream, and Darley Beck itself is actually not a major, it might be bringing in polluted water, but it's not of itself, in fact, the reason for poor conditions downstream. And this agrees with, as far as I can see, the fecal bacteria data that David had analysed a couple of years ago in 2021. You can see the numbers here, bearing in mind that 1,000 figure before. Here's Duffer's Pool, 1900, 2600, 19, and they're all pretty much in the same ballpark. So both from the point of view of the fecal bacteria and the point of view of the diatom data, both are actually saying that the pollution problem starts upstream. It may be you've got all kinds of local problems, but on the NID. So my question is it Pateley Bridge? Is that where the sewage works? Or other upstream agricultural sources or other sewage works upstream? But it suggests again the wisdom perhaps of looking at the whole system in the context in the way that we did for IWARF. So just to sum up, key points. Sewage effluent is the most important cause of nutrient pollution in the Wharfe, and discharges from the Ilkley sewage treatment works. Final effluent is the most serious pollution source in the river. Datum data indicate there's a problem in the Grassington area for us. Our tributaries are in poor condition, and we're not entirely sure, but it will be a combination of agriculture, surface water runoff and septic tanks. We should, however, say, for the Wharfe at least, and certainly the upper part of the Wharfe, it's actually in pretty good condition when you compare it to the condition of most other rivers in the country. And then for the NID, the provisional data that we have indicates that it's also polluted by fecal bacteria nutrients, and that pollution sources upstream are more important than discharge from the Darley sewage treatment works. So, thank you very much.
Thank you. Well, thank you, Rick. You've opened up a whole world to us, and with facts and figures. That's absolutely marvellous. I know that supper is going to come in pretty soon, and I know that Ian wants to give us river management update. But very briefly, are there any questions that you want to ask Rick at the present time? Yes, Luke.
Hi, Luke.
Very quickly, brilliant talk, thanks very much. I noticed the baseline on both the NID and the Wharfe, the eco line, decreases at your downstreammost point, and it's not very far between the upstream point from that downstream point. So we know there's decay, natural, I just wonder what that means for looking at a big attachment, and also in terms of cleanup.
Yeah, I mean, good point. The data there are a little bit biased because that sampling point with a big peak, in fact, is very, very close to the outflow. And I think at that point, it's actually the plume from the discharge is not fully mixed into the wider river, in fact. Now, that's important if that's where people are actually bathing. But in terms of doing it, looking at it in the context of the bigger river, a sampling point somewhat downstream once the actual plume is being mixed in. And I think that high point would probably look a little bit more similar to the other points downstream. But there is this complete issue of the sources, the die-off, and the weather conditions in terms of the fecal bacteria. In terms of the nutrients, again, it's different because downstream as well, there are some sewage works where the phosphorus is being removed, so that will also alter those concentrations too. But it's not easy to capture in one snapshot.
Exactly.
But a snapshot is very important because you're controlling at least for weather conditions. You need multiple snapshots. And the problem with the Environment Agency data is that they go randomly, in fact, really. I mean, purposely randomly.
And less so every 3 years now.
Unless so, and they sample what is a very dynamic system. They're sampling it just once every 3 months sometimes, in fact. So it's very, very difficult to compare one sample point with another sample point unless you generate enormous numbers of data points over many, many years. So I think the best way to look at these systems is actually by this snapshot approach, but the snapshot needs to be repeated in winter and in summer under the different weather conditions. And always be aware of the limitations of the data.